So I have to say it is humbling every time I look at someone's bio and I realize there's something I did not know about them. So I did know that, guys, get a room. Tim, get a room. All right. Okay. So I first met Jim Tananbaum, strangely enough, at a conference on neural networks applications to medicine in Long Beach, California. But then I learned that he was one of our great HST graduates. HST is the Health Science Technology Program of Harvard and MIT. Despite what one of our speakers said, you can actually be both great in medical school and great in computer science or in technology. And so what I did not know was that Jim also got an MBA from Harvard. Is that okay? And he's went on to generate several large companies in the space of pharmaceuticals, but because of his training and because of his interest, he's involved in a variety of companies involved in bringing data to the problems of healthcare. And I don't want to say too much more on that, except to say that he actually shows how someone who was trained in math and computer science, as he was at Yale, I'm sad to say, can then bring in medical school that to bear to actually advance medicine. And so I think what you'll hear is the experience of someone who understands what medicine is about, understands its limitations, but also has, I believe, realistic plans and thoughts about how one can take this system under siege and bring some efficiencies, rationality, and better treatments to it. So thank you very much, Jim.
Thanks. Hello, all. Great to be back on Avenue Louis Pasteur. So I'm going to try and stick to the questions being asked today about how AI can accelerate precision medicine, what's the right place for AI, and what are the right problems to solve. I'm going to try to stick to the big picture, be a little provocative, but there's a lot of detail behind these comments, and I hope we'll have some interactivity and be able to drill down on some of the things that I'm going to cover. Okay, so first, I do believe that our healthcare system is messed up in the United States. Some people actually feel like it's on a good path. I actually feel like we're hitting the natural end of the innovation cycle of the last 50 years in healthcare, and that's why things have become increasingly difficult. Mary Meeker publishes a report every year. Healthcare gets covered in the report. There are lots of good statistics there. I'll just give you a few. According to Mary, and this is 2014, but things have just gotten worse since that report, but I thought this was an interesting statistic. She was estimating about 27% of healthcare costs are waste. Employees carry $620 billion of expense, 28% up over a 5-year window. Individual costs going up, 25% of income. The top 5% of chronic diseases spend 50% of the healthcare dollars, and 50% of all personal bankruptcies relate in one way or another to healthcare costs. Chronic conditions equal 75% of spend for the whole system. So how have we gotten here? I'm going to try and maybe stick to some observations and, again, stick to the big picture, but I think that one big issue is alignment in our system right now. So currently, people move in and out of insurance policies on an average of about 2 years. Now, there are exceptions to that, but I think for the as a core assumption, I think this 2-year churn is a reasonable assumption. And what's happened is this 2-year churn, I believe, has driven the entire system away from long-term prevention and into alternatives for outcomes within shorter windows, and also it's pushed the innovation cycle into solving those diseases that have a huge cost impact in a relatively short period of time, which are monogenic diseases that don't have good solutions, and cancers. And so I believe the whole R&D infrastructure of the US and the rest of the world follows has been moved away from what kills most of us over our lifetimes into what the customer, the payer, is actually paying for. So then I think in order to look at this and ask what's the right way forward, I think you have to step back altogether and say maybe the current system, we're just kind of asymptoting in our efficiency in the current system. And let's just start off from scratch and just look at the big picture things. What are the things that kill us, and how do we prevent those things using all the tools that are available for each and every one of us as individuals? So, what are the major things that kill us? Heart disease, cancer, type 2 diabetes is underneath it all for a significant number of people, and so on. So already we have a variety of tools at our disposal that in each and every one of us we could use over the course of our lifetimes already to help us live a much healthier life, a much longer life than the average person is going to live in our current healthcare system, because these tools are not getting applied properly. So first thing is, and we recognize this as many, I see virtually everybody on their cell phone on the breaks, we have closed-loop learning systems all around us. Every time we use Amazon or Google, we're participating in a big experiment. These closed-loop systems have digested the patterns of billions of uses and users, and it's constantly testing whether we fit the pattern that it thinks that we're fitting. And it tells us and serves up for us suggestions as to what are the desired things for us to buy, or questions or answers for us to look into for questions that we're posing. And it sees how satisfied we are by that and readjusts its model. So there's a whole technology framework which has robustly been deployed over the last several decades and has led to revolutions in many segments of the economy. Also, in healthcare, key parts of information have dropped in cost. Key parts of information, basically what I'm getting at is sequencing. So, at the end of the day, we have our genetic code, and then we have what environment has been influencing us as we grow and develop. And the cost of looking at our genetic code very deeply is dropping to a place now where I believe it's going to, over the next couple of years, be tens of dollars, basically for reasonable deep sequencing. And so, so that's, I think, another major driver. And that allows information, which might be one of the key missing pieces of information that can help us individually manage our care better. That's also coming online. And then also ground truth data, in addition to sequencing, labs, images, all sorts of things are now readily available in mass. And then on top of that, we had talked earlier, and we've heard a number of people talk about taking existing medical records and other pieces of information that the system has developed. I actually believe that most of the AI applications that we're seeing for funding and that I end up running into are in the context of the current system. So in one way, I take a look at the current system and I say, wow, if I could just take all these medical records and put them into some kind of a learning framework, then, if I do enough of this, then I'll be able to use AI to do all sorts of things. But then we also heard that there's a lot of noise in that. But to me, the picture or the discussions are really all in the context of the current system. I think the bigger question is, well, what information content do we really need in the end to help make reasonable decisions for the vast majority of us on a precise basis? sequence labs. I mean, there are, I think, as it turns out, not that many things that we need to keep track of for many of us over the course of our lives. Now, that's not the case for 5% of the population. It's not the case for people that have multi-organ diseases or other things that are idiosyncratic. But it is the majority for, I think it is the case for the vast majority of us. So what this means, basically, is right now I do think that if we don't get hung up in the current system, but rather just step back and ask what we have, take an inventory of what are the tools and technologies that we have at our disposal, that we do have a basic framework and tools to absorb the patterns of human disease development at very large scale. And then we have ground truth measures to assess whether us as individuals are fitting patterns of common disease development over the course of our lifetimes. So I do believe that the next innovation cycle in healthcare is going to be about precision prevention. And I think it's going to be a very different framework than the framework that our current system exists in. I'm going to try and bounce back and forth between trying to give some specific examples now of what it means, because I think there are a number of things that are actionable, and it's really stunning to me that our system doesn't act on it. And then I'm going to try and come back to how to get from here to a better system. So I've been told, I haven't checked this, but I think it's accurate. It comes from a good source. One of our portfolio companies, a clearinghouse, largest clearinghouse for provider-identified blinded aggregated data in the U.S. I've been told that there are about 1 million people in the U.S. with LDL above 120 that have documented coronary artery disease. I think that is just a stunning statistic. You step back from that, and in this day and age, with all we know, what is going on in our system that we can't get those people down? And I think there's several issues. First, I don't think our system is oriented to care that much about it. Anecdotally, cocktail conversations, I ask people all the time about how they think about their own predispositions to things. And most people report to me that their doctors continually tell them that diet and exercise is the way for them to control their being overweight by 30 pounds or whatever it is. But the fact is that, if they're overweight by 30 pounds, behavior modification or whatever it is their doctors are telling them is not working. And many of those same people have elevated LDLs and probably have prediabetes, and no one's really looking at that. And then on top of that, for those cases where people do look at it, they take there's a percentage of people that take their statins and take other drugs that they're given, but then there are a percentage of people that don't, or don't even know how important it is to do it, and aren't really continually tested as to whether they're doing it or not. And the fact is that just closing the loop and continually testing, just taking those 1 million people that have LDLs above 120 and doing whatever you can to get those LDLs down, and many of them would just be treated with generic statins, but they're either not taking them frequently or they think that it's causing muscle pains or whatever it is. But then there's just a bunch of people that, for whatever reason, aren't very compliant. It's the same story in my mind of the person that's being told they're 30 pounds overweight, they should diet and exercise, but they haven't done it. And so then I do think that there is room for real-world therapies, and when I say real-world therapies, I mean therapies that work in a setting where you're measuring a response that will cover the population that just don't work on the inexpensive things. And an example of that in the LDL example is PCSK9. And what I'm thinking about in PCSK9 is yes, the antibodies, but actually the antisense product that the medicines company is developing, and it's a 6-month product. And I think it's really interesting pricing conversation because if you look at the antibodies and the launch of the PCSK9 antibodies, they're a remarkably powerful drug, and they really are not getting used at all. And I think that it's an interesting reason, in some cases, a breakdown, I think, in several aspects of the system as to why the adoption's been so slow. But rather, again, to drill down on that, just to step back from it and to say, well, I think if the medicines company were to come out, and again, I'm not, I don't know if this is what they're going to do, but if the medicines company came out and priced their product at a couple $1,000s a year, all of a sudden, this fits into the 2-year churn framework that we have right now, where those patients that have LDLs of above 120 and aren't controlled by whatever they're being told to do could get this injection once or twice a year, and the system would end up being cost better off and outcomes better off. And by the way, the longer that somebody stayed on that program, the more value accrues both to them and to the system. Now, this example, I think, you look everywhere and see this example. Type 2 diabetes is another one I think is a remarkable disease, and it's one where it's very prevalent. The studies have been these massive retrospective studies. They've been monolithic, and in a real-world setting with the data and systems that we have at our fingertips, we're going to be able to do much different types of studies. So very quickly right now, I think most people would not argue that metformin is probably a great starting drug for type 2 diabetes. But there are other drugs, too, that get very frequently added to metformin. The one that's my pet peeve, and this is a controversial statement, but I have data, scalable, sizable data that's not published yet, that supports at least part of this, which is I think insulin gets overused dramatically in the type 2 population. And if you look at the injectable market for type 2 diabetes, 85% of it is insulin and 15% of it is GLP-1. And there's a whole bunch of other generic drugs that get sprinkled onto type 2 diabetics. And then there's GLP-1 and SGLT2 products. And I think those products have been, those two products, the SGLT2 and the GLP-1, because they've been taken forward over the last 20 years in the FDA in a modern cardiovascular framework, those have been the most extensively studied. And it's remarkable what those two products do for type 2 diabetics that are responsive to them. It basically makes them live longer. For GLP-1, it also reduces weight. So now what really needs to be done, and which can be done, is a real-world study that looks at all of these sleeves simultaneously and then is measuring A1C, and just a few ground truth measurements of disease progression. Again, there's not very many things we need to look at in order to measure how these various products are affecting individuals. And in fact, that type of project can go on now and will go on over the next few years. And the systems that are set up to do it are the National Health, the NHS of the UK is set up to do it. There are a couple other countries that are set up to do this kind of thing, and now places within the US are set up to do this kind of thing. And so hopefully we'll start to see very, very large-scale trials that have control arms in a real-world setting that can start to get at these questions. But to me, the bigger take-home message from this is that when we set up a system where we've absorbed the patterns of human healthcare development, and then we have a testing framework around that, which is based on ground truth, and then we're continually assessing whether the individual is meeting the pattern that we think that they're meeting, that's a very powerful generalizable framework. And so I can keep on coming back to that framework again and again in various examples. I'll give two other kind of orthogonal pieces of technology that I think are going to be ubiquitous and that are developing. So, and it's around sequencing. And basically, we're all aware of monogenic disease development. We had a lot of discussions about it today. And that, certainly has had a profound impact on being able to treat a series of orphan diseases primarily. However, for many of us in the audience that have been fortunate enough not to have combinations of single genes, we have lots of little genes that are contributing basically to disease development and will skew us to one type of disease development over another. These calculations are called polygenic calculations. They're also controversial. They're controversial for a number of reasons. The first part of the controversy relates to the calculations that have been done on primarily white males. But that's an inclusion criteria conversation. And the calculation, just for example, for cardiovascular disease that Casheration at the MGH did, basically took a series of, I think, thousands of different genes and in various combinations where the weighting factors for all these combinations weren't published, but basically they were determined in a Mendelian randomized, statistically well-done way and then prospectively cross-validated. It basically says that if you have a score, let's just arbitrarily say a high polygenic risk score means you're going to have 4x the cardiovascular, 4x the heart attack of somebody that's age-adjusted for you. So then if you then took, the first question is, well, what percent of the population is that? And my sense of it is about like 12%, so it's a very meaningful number. I may be off a little bit on that, but it's way more meaningful than what you would expect from monogenic diseases. And then the next question that you would ask is, well, if somebody that has a high polygenic score, is there anything you can do about it? Well, the fact is that the populations that SEC used to run these are large enough that you actually have LDL dose response curves. And the punchline is basically that a polygenic high scorer with an LDL of 30 has a normal heart attack, has heart attack frequency in line with the normal population. And so the punchline is that there's a subgroup of people with high polygenic score that could be treated more aggressively and would end up pushing off dramatically heart attacks in their lifetime. There are a couple dozen other polygenic calculations that I'm aware of. Most of them aren't published, and most of them need proper balancing in terms of populations and scale. But all that's coming, and so germline polygenic predispositions to disease, I think, is a major category of measurement, which is right now becoming very real. The other side of that is somatic disease development. And there also, I think there have been very big breakthroughs. I think it's also driven by the dramatic reduction in sequencing costs that have happened and are now about to occur. And basically, through normal cancer screening mechanisms, we pick up a fair amount of cancers earlier and earlier. And now using cell-free DNA analysis, and this is just on the cell-free DNA, but there's also, I believe, other omics that are going to get added to this that make this even better. But the punchline is basically that out of 100,000 people that are screened, 500 metastatic cancers will be missed. And this blood test will pick up, without any kind of bias for the cancer type, it will just pan-cancer pick up 250 of those 500. The other side of that question is, well, what's the false positive rate on that? And it turns out the false positive rate is, right now at least, about 250 as well. However, the tissue of origin of the somatic aberration is also delivered with the test. And so it's our belief that you'll be able to go back and then re-screen for the tissue of origin and to then dramatically reduce the false positive rate of discovery from this. And by the way, this is a learning system, and it seems to be getting better. And as I mentioned to you, it's really just learning off of a narrow set of dimensions, and as other omics get added into this, we expect that it will get better and better. So, again, what this means is today, over the next couple of years, at our disposal will be ground truth tests, blood tests that look at our germline, give us our predispositions to things. A lot of those will be polygenic, but also somatic analysis. And then when you put that against a background of routine screening, gives us as individuals a lot of authority to live the longest life that we possibly can live. So what that means, I believe, is that we could set up a testing framework, and that testing framework I think, will be way more efficient than the current system that we have, because you're removing a lot of the noise. Again, you're just coming back to ground truth to look at, coupled with the predispositions that we're going to have. And this is what will end up covering 90% of the diseases that we're going to worry about. And it will drive the spread between addressable actions we can take to prevent disease development and what is actually done in the real world, which right now, given the 1 million people that have LDLs above 120 and documented coronary artery disease, is a very big spread. So, so I'm told that actuaries believe that 50% of the people born today are going to live to 100. No one knows exactly how that's going to happen, but that's the prediction based upon the trends. And so I fundamentally believe that we're not on that curve right now, given our system and all the inefficiencies that are measurable in our system. But that there at least is some alternatives that are now starting to develop that are very likely to get us there. And I think in this new framework, basically what we're seeing is HMOs approaching CROs, where basically we're absorbing patterns of human healthcare development. We're doing relatively lightweight things to measure in each and every one of us how disease is developing in us given our environment and other things. We're taking action to screen and prevent those things with medicines where there's ability to take action, getting the cancers detected earlier and treated earlier, getting heart disease more aggressively treated. And so we're running a continuous trial at the delivery level, which basically means we can plug in development at the delivery level in a much more efficient way, and also, I believe, research. So that's the area that I think that AI is going to have the biggest impact in medicine over the next 10 years, and it's with the proper framework and infrastructure to leverage what AI is set up to do.
Thank you very much.
Yeah.
So I'm sure you have a few questions, but as people have their questions, I'm glad to start with my own. So I was watching, I was just tweeting out your talk, and several people agreed that the 2-year churn is a big part of the problem. So you're in the space of actual companies having to deal with actual 2-year churn. So how are we going to have business plans that pay for this kind of thing in the 2-year churn model?
Yeah. So let me just make sure I'm answering the right question, because I think what you're asking is, how do we get from a system that has a 2-year cycle into a learning system where there's no bridge to that, right?
Yeah.
It's not like we're going to just say, like we're going to pass a law and the churn is forever. The likelihood in the U.S. of having a socialized healthcare is, and by the way, socialized healthcare, although it would solve the churn problem, would create a lot of other problems. So so I believe, and this is certainly, I think the way the markets work in a lot of places, is that you have to start where there's alignment. So you have to start within that 2-year envelope. So you have to define diseases where within that 2-year envelope you can work within the system. And this LDL example that I was giving was chosen basically for that framework, because that sort of population has documented coronary artery disease, ICER. There's a whole bunch of different places that have looked at the cost of those patients to the system, and it's a few $1,000s a year. And so now you have a framework where a $2,000 a year product can come in, like a PCSK9, and take that entire patient population group over. Okay, so now the next part of that, which I think is a remarkably interesting part, is when you look at the pharmaceutical industry, which I think has kind of screwed up a lot of this discussion to date, when they launched their PCSK9 products and they did their pricing analysis, they basically more or less tried to figure out exactly what the price was the system could handle, not what was the right economic price for the product to deliver the most amount of value to a payer in a 2-year framework.
That's right.
Right, okay. Now, here's what they did, which is crazy. So they come out with a $10,000 price and they end up getting no volume. All right, now let's just think about this. 1 million patients with 120 and, basically times $2,000 a year, that's $2 billion, okay? If they had come out with a pricing paradigm like that, had gone to payers and said, we're going to give this to you, but just give this product to everybody in your system, rather than put like barriers up on formulary, push this through your system for anybody that's just, for whatever reasons, not responding to statins properly. And by the way, that paradigm, I think, is going to start to happen. But that's where it starts.
Okay.
Yeah.
So I apologize if I'm peeking behind the wrong kimono.
Yeah.
But, okay, how do you actually begin to have that conversation?
Yeah, well, it's being had. You have that conversation, right? Let's see, a few things. First, the medicines company is going to have a product, and it will get approved.
But they're still asking for a lot more than the number that you said earlier.
In terms, actually, do you want to go from 2 years to 3 years to 5 years?
No, you said for 2 years, $2,000?
Yeah.
Do you think the insurance companies, the pharma companies will price the product appropriately?
Oh, yeah, okay, all right. So the first thing is, I think the medicines company has a really difficult question in front of it, okay? So here's the reality. The reality is that Amgen and Regeneron had combined $1 billion worth of sales now, 4 years into the launch of those products, okay? So if the medicines company goes into the existing marketplace, it's going to have a very small percentage of that on a revenue basis. And so its launch is going to be slow and expensive, and it's going to require a lot of reps. And that just won't work for that company. And by the way, what's gone on now as a result of these 2-year churns and the inequality between pricing and being able to tie it back to real value is that launches have gotten pushed off in terms of their peak revenue, which basically means that a lot of these small companies, in fact, even larger companies, aren't getting paid for bringing products to market that are the products that affect all of us, because there's just a total disconnect between how long you have to sell the product against all the restrictions and how they're getting paid for it. And so my view is the medicines company is going to have one of two choices: either to be sold to another large pharmaceutical company, if somebody will step up for that, and they'll either screw it up or do it properly, or basically say, we cannot fight a pharma war. We will not have the money to do that. We have to have a model that is very efficient for us to sell. So we want to get rid of our sales reps, okay? We want basically to have all of the value getting direct to the patient with the most amount to gain from it, so that we're not diluting, basically our income over all this friction. So what that basically means is you take a launch curve that for a normal launch, if they were to go out and say, oh, $4,000 product and, blah, 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 they'd have 5-year peak sales, okay? Another conversation, $2,000 product with the right set of payers, pull it through, it's like a step function. And by the way, I don't know if you've seen this, but the state of Kentucky set a deal up with Gilead for hepatitis C treatment. $100 million, I think, covers the whole state.
Wow.
Okay? And by the way, this is a whole other way to have this conversation, okay? But the point is that what you're doing is you're taking a launch curve like this and you're turning it into this. And you're doing it at a third the price, but then you're matching, 10 times the volume very precisely, because you can. And then, by the way, the next place to go with this is, so if you were to match the volume, so right now if you look at PCSK9 use, it's all over the map. Those people with 120 LDL with previous documented coronary artery disease, yeah, some percent of them get PCSK9, but many of them don't. And so now if we were to then take out that population because of that 2-year envelope, and you ask yourself, okay, at the end of 2 years, what's the value of that patient? Okay, well, the value of that patient has to be higher than the value of the untreated patient, right? Because of all the ICER calculations. In fact, what ends up happening is the value, right, ends up accruing. The longer you're in these programs, okay, the longer you're treated, the more likely you are to remain healthy, the more valuable you are to the payer. In fact, the payer loses you, odds are he'll replace you with somebody that hasn't been as well controlled. So as time goes on, you become increasingly valuable, which means that there's money to be paid for loyalty, which would remove co-pays and other things. And that's how you go from 2 years to 3 years to 5 years, right? So, yeah.
Well, that's actually, contrary to the way you opened that, a very optimistic view of it. And it sounds good when you say it. I worry that whether there are others in our ecosystem, but I take your word for it, there are others who are having that conversation.
Well, so I think the really interesting thing is that there are going to be products that perform incredibly well in the real world, and there are going to be ways of measuring them. And I love this. The medicines company is an easy one. It's a 6-month product. We have another company that has a GLP-1 implant that's a 6-month product. And and again, if I'm going to do everything I possibly can to help the company get to a place where it's pulling through volume, in exchange for reduction in sales force. And it's a price conversation in the end, because really to get alignment with the payer, you're really going to have to go way down on price in order to do it, but the volume's there.
Well, that's enormously enlightening. I have from a former Harvard medical student to a current Harvard medical student.
Okay.
Yes.
Hi, my name is Mugda again, currently a Harvard medical student. I was speaking to a cardiologist recently. He gave me a whole lecture on heart failure medications and went through guideline-based therapy and said, we put everybody on these 5 drugs. And then I asked him at the end of the lecture, I said, can you tell me about what the hubbub is about precision medicine related to heart failure? And he said to me that realistically, it may be a great thing to do for medicine, but it's not going to happen because right now, 20% of the population is on lisinopril. What is the incentive to do research that says, actually, lisinopril is only good for 30% of people and not the other 60%?
Yeah.
So if you could speak about the feasibility of that.
Yeah, this is another variation on Zach's question about PCSK9, right? It's the same conversation. Why in the world would anybody do more work on the things that kill all of us? So, okay, so now the first question. The first thing that I actually want to get to is the bigger question with heart failure, okay? Because I think what constantly it's easy to get to happen is to get drawn back into the current system. In order to, I think, ask what is the right thing to do, you have to step back and just say, okay, blank sheet of paper, what's the right thing to do? And now let's try and figure out where the breakdown is. Okay, so to me, heart failure is a really interesting paradigm. By the way, renal failure fits the same paradigm. And the paradigm is basically the more aggressive the heart failure gets, the more hospitalizations occur, the more expensive the patients are. Okay, so actually, if you just start thinking along those frameworks, then the question becomes, well, how can I prevent those hospitalizations? What do I do on a precision way to push out the next hospitalization? Because that's, again, within a cost envelope, that's the big picture, right? Okay, and that's not a lisinopril conversation, okay? And by the way, when you look at what the cost per hospitalization is for a heart failure patient or for a renal failure patient, it's a lot. You got a lot of money to work with on that. Okay, so there are, again, a couple ground truth measurements that are very good predictors of heart failure decompensation, and they're not weight gain. Weight gain is it's too late. By the time you start to see a dramatic weight gain, you're going to be hospitalized. So one of them is an impedance measurement, and the other one is not published off of cytology. But the bottom line is that there are good methods for 3 weeks before decompensation. And to me, again, that becomes you know, the within the cost envelope conversation, like the way to look at where innovation is going to happen first in those areas. Okay, then there's a next question, which is about predisposition to heart failure, and there's a whole genetic conversation that's playing out there, and various subcategories of heart failure that have availed themselves, and very specific treatments that are coming along. And I do think, again, there's a pricing envelope that you trade off volume, okay, for you know, for share, I'm sorry, volume for price, and they do pay out for most people, and I mean by far pay out for most people, and so then you're, you know, in a place where lots of heart failure patients are now living way longer, you know, and having, you know, outside of hospitals as a result of a combination of understanding of the more precise mechanisms in a person, plus ground truth measurement. And I think that's the innovation cycle, you know, basically over the next 10 years for heart failure.
And I apologize, this will have to be the last question because we ran out of time.
Yeah.
So my name's Mohammed. I'm an undergraduate. So you were talking about PCSK9 and trying to increase the churn cycle by having a payment plan, sort of deal with by letting drug companies have a payment plan. So my question was like, if there's always like a risk that the patient like bankrupts him or herself, and the payment plan doesn't come to fruition, so who would be best suited to orchestrate some sort of like 2-year plan to pay, like a drug company, an insurance company, or a hospital, or?
Well, I think so. So there are lots of. I think there are many different ways of answering the question. That could work. I like the one I like. Okay, is one where the patient pays nothing out of pocket, no copay. Okay, the insurance company pays because they're getting a better patient outcome and a higher HEDIS score, and frankly less cost across an actuarially defined population. And then basically that same patient, okay, that's not paying anything out of pocket for their drugs, and by the way, that patient is being measured, and their doctor, by the way, gets a little bonus payment if they're at goal. Their doctor, by the way, doesn't get their bonus payment if they're not at goal. So their doctor's calling, all the doctor has to do is just read the labs, you know, and by the way, the patient, I think, can be put into a standard program that would be away from the doctor, and by the way, I do think that we're going to start to see real-world programs that take a lot of the care management aspect of this type of thing into a framework, testing framework. And so that what ends up happening is that the doctor basically has an incentive to put a patient into that and to call the patient up if they're not, you know, if their measurements, their ground truth measurements aren't what they should be. The patient has an incentive to stay in the program because there's free product. And by the way, then there's a loyalty incentive that basically is along the lines of the more ground truth measurements you hit, you know, it potentially unlocks more free copays and other things because you're increasingly desirable for that whole system. But that's one, you know, that's one way to, you know, imagine the story playing out. But there are others.
So I apologize, but this is truly the end of our meeting today. Thank you very much, Jim.
Thank you. Thanks. Thank you all for weathering it.
So I just want to thank you all for being so attentive, for all the great questions, and I look forward to seeing you a year from now at our 6th. You will see most of these videos online shortly at a place that you can reach through the Department of Biomedical Informatics website. Thank you very much.